The Andromeda Nebula has been known to man since ancient times. The first to notice it were the Chaldean priests, astronomers of the ancient world. At some point in the past, the Andromeda Galaxy was the spitting image of our home, the Milky Way. But with the development of astronomy, this myth was dispelled. It turned out that the Milky Way and Andromeda belong to different subclasses of spiral galaxies, and the configuration of their arms is quite different. But nonetheless, they still have a lot in common. For example, an appetite for devouring their dwarf satellite galaxies. Their internal structure is also similar. The Andromeda Galaxy, also known as M31, looks like a spiral, the lines of the arms of which being evenly dispersed around the spherical bulge, the central, bright part of the galaxy, which consists mainly of old, bright stars moving in extensive, elongated orbits. The Milky Way today, on the other hand, is assumed to be a galaxy of the SBBC classification, a barred spiral galaxy. The difference between our galaxy and M31 lies precisely in the bar. This is the portion that extends from the edges of the bulge and connects it to the arms. The nucleus of the Andromeda Galaxy, like the nuclei of many other galaxies in the universe, has candidates located in them that have the potential to become supermassive black holes. Based on the results of calculations, the size of such an object could exceed that of up to 140 million times the mass of our Sun. In addition, the Hubble Telescope discovered a mysterious disk which contained young blue stars surrounding supermassive black holes. They revolve around a relativistic object in exactly the same way planetary bodies do around their stars. Astronomers are a bit puzzled by how this kind of a disk could form so close to such a huge object. According to calculations, the enormous tidal forces of supermassive black holes should limit the gas and dust clouds from coalescing and forming new stars. Well, further observations will likely provide us with clues to this mystery. According to rough estimates, the Milky Way may contain between 100 and 400 billion stars. But this is nothing compared to Andromeda, which may contain about 1 trillion. Thanks to the Hubble Space Telescope, among this trillion, scientists have learned about the presence of a very large and sparse population of hot and bright stars. Hot young stars tend to appear blue. However, the blue stars found in the Andromeda Galaxy appear to be growing old, more like the Sun, stars that have burned out their inner layers and are revealing their hot blue cores. They are scattered all across the center of the galaxy and are the brightest in the ultraviolet range. Besides that, there are other interesting objects located in the core of M31. Along these lines, a double or a binary cluster of stars was discovered in the center of Andromeda Galaxy. This discovery turned out to be highly prized by the astronomical community, since the merging of the two clusters into one could happen over a fairly short period of time, roughly in about 100,000 years. Based on calculations, astronomers have determined that the merging should have happened millions of years ago. However, due to some strange and still inexplicable reasons, it did not happen. According to one hypothesis, there may not be a double cluster at all in the middle of M31, but rather something like a ring consisting of old red stars. The ring might look like two clusters, because when observing, we only see the stars from the opposite side. The ring of the disk is turned to our galaxy on one side, from which it can be concluded that there is a certain interrelation between them. When studying the center of the Andromeda Galaxy using the XMM Newton telescope, A group of astronomers also discovered 63 discrete sources with X-ray emissions. Most of them, that being 46 objects, have been identified as binary X-ray stars, whereas other objects are acting as neutron stars or candidates for black holes from binary systems. About 460 globular clusters have also been registered in the galaxy. The most massive of them, Myal-2 or G1, has a luminosity greater than that of any cluster in the local group. It is even brighter than the brightest cluster in the Milky Way, Omega Centauri. It is located at a distance of about 130,000 light-years from the center of M31 Galaxy and mainly consists of about 300,000 old stars. Similarly, the PA99N2 star is located in Andromeda, around which orbits the exoplanet, which is the first to be discovered outside the Milky Way. But as it stands today, the planet is still considered to be unconfirmed. However, in view of the scale of the Andromeda system, the presence of so many stars in it, and an even larger number of planets, it is quite possible, at least according to the logic of the theory of probability, that among this abundance of planets, there are planets that are quite suitable for life, or already have life on them. After hundreds of thousands of years, we will be able to see everything much better, given the fact that a collision of the Andromeda Galaxy and the Milky Way is inevitable. Mind you, this will happen in about 4 billion years. We'll be substantially older. Well, we tried to put together all the most interesting facts about our celestial neighbor. If you want to find the Andromeda Galaxy in the night sky, then the best time to observe it is the autumn and the winter. In a dark sky out of town, it will be visible to the naked eye. What's interesting is that because of the finite speed of light, we are seeing this object as it was 2.5 million years ago. Shall we say 2.5 million years ago on Earth, there were no representatives yet of the modern human species. Unfortunately, according to the theory of special relativity, there is no way to know what this galaxy looks like at the present moment, given that what we see is for us the present moment.